I'm here to talk about scaling Icinga2 with many heterogeneous projects. And as you can notice by the date at the bottom, it's not the first time I am doing this talk. I prepared it for the OSMC in last November in Nuremberg. And after that, Michael said, hey, we have an Icinga camp in March. Could you repeat the talk? And I was, yeah, okay, if there isn't too much overlap in the audience. So who of you already knows this talk? Okay, that's good. If you don't want to hear it again, I'm not mad at you if you leave now and drink a coffee and save the first spot in the lunch line. But for everyone else, it seems to be new. So one of our goals with many heterogeneous projects is to still preserve configurability. So we'll go into that a little bit later. Why am I here today? Last year in April, I attended the Icinga camp here in this room, and I was sitting there, and it was a nice event, but I was a little bit disappointed because nobody seemed to have the same problems that we had with our Icinga infrastructure. And I was looking for people to talk to, and everyone was, no, Icinga works great. And I was like, yeah, it works great, but we have problems, and I want to talk to you about it. And so I decided, if I can't find people with our problems, maybe I should just get up there and talk about our problems. And then maybe people will answer to me and say, oh yes, yeah, we have this problem too. And it worked pretty well. At the OSMC, I talked at the first day, and then I was busy for 3 days talking to people about their Icinga infrastructure. And it was amazing because I learned so much. And I realized we aren't the only one with problems, and we aren't the only one with solutions. So yeah, it was really nice. So that's the reason why I'm here today, to recycle this talk and to talk to you again. I want to provide you with some real-world example how Icinga can work at a larger scale. I mean, we don't have the largest Icinga setup because I don't have a Mac here now. But yeah, it's not small. So how does it scale, and how do we actually deploy an Icinga2 configuration in our setup? Because there are hundreds of tutorials online. How do you set up in a single server Icinga instance? But there's no tutorial. How do you manage the configuration for a few thousand hosts? So that's what I want to show you today. I'm here for SysEleven. SysEleven is a managed hosting company in Berlin. And additionally to our managed hosting, we have an OpenStack environment called SysEleven Stack, or on top of it, we have a managed Kubernetes cluster, MetaKube. And finally, we are also an internet service provider. This is just because we have a really awesome network team. And at some point, they said, okay, our own network is so great in Berlin, why don't we start to sell it? And now we have a lot of business customers with internet access. Currently, we are about 100 employees. And yes, as I said, I'm Max, and if you want to find me online, I have Twitter and GitHub. My nick is Ekai. Feel free to tweet about the talk or check out my GitHub repositories. To give you a little bit of context about our infrastructure, we have 2 data centers in Berlin, and we have around 3,000 hosts and 65,000 services. And all those hosts and services are distributed in several hundred customer setups. And every setup is a little bit similar, but also a little bit different. So we have to change settings in our monitoring for every customer. And that's what I mean with a heterogeneous setup and configurability, because we have to have some way to change everything. And until January 2018, we used Icinga1. And then earlier we started to migrate from Icinga1 to Icinga2, and I will talk about this also because it's a real-world example how we can migrate technical debt into an awesome setup. And the migration took about half a year. So I really like the order of the talks today because the first talk was a lot about technical debt, and I was like, okay, been there, done that, yes. And so at first, in a real-world example, I want to talk a little bit about our technical debt, so you understand what we came from. SysEleven started as a very small company, like 5 people, and they used Nagios. Then they decided to migrate to Icinga1, and then the company grew really fast, and now we are over 100 people. and we ended up with 6 independent Icinga1 servers and a central SVN repository to synchronize our configuration. And if an engineer wanted to change something, he or she needed to log in to the production server, manually edit the configuration, reload Icinga, manually create a SVN commit and push it into the repository. And as more people as we became, we started to forget to actually commit the changes. So we started to have a cron job to commit all changes every 5 minutes and then synchronize it to 5 different servers. And you can do this if you are like 3 engineers, but you can't do this if you are 30 engineers and everyone changes stuff every day. So it became a mess. And then later, Icinga1 announced the end of life for 2018. So this was one reason more to shut this off. And as we are still talking about technical debt, we had an interesting issue with Icinga1. And it's very small font, but the interesting part is the green line. And the graph shows the average check latency of Icinga1. And here it is at 3 minutes, but we had days when it was worse, like 15 minutes or 20 minutes. And what this means is something goes wrong in your infrastructure, and 20 minutes later you will receive an alert from Icinga1. This alert doesn't matter because you are already on your phone because your customer called you and said, yeah, we are offline. And as a managed hosting company, we always want to call our customer and tell them, yes, you are offline, we are working on it, but we never want our customer to call us telling us that they are offline. And so luckily we found this issue really early, so it didn't happen often that this went up to 20 minutes, but we never found a real solution. And at the OSMC, actually, someone else came to me after my talk and said, yeah, we had this too. We have no idea why, but it happened. So, and it was already at a point where everyone was, yeah, you are running Icinga1. What do you expect? Please migrate to Icinga2. So, but we found one workaround to, yeah, still talking about technical debt. In the beginning, this was one line in our internal documentation. You just pasted it and hoped for the best. And so I don't want to make fun of my coworker because it's amazing that he wrote this and it helped us. It takes the worst 60 checks from Icinga1 and then forces Icinga1 to recheck it. And if you do this several times, you will only have 1 or 2 checks left with a bad check latency, and then you can figure out what's actually happening with these checks. But before that, you have like 5,000 latency checks. And so, yeah, this is not really maintainable, but it's a workaround, and it helped us to keep those 6 Icinga1 servers running for a few more months until we had a replacement ready. If you are running a larger infrastructure, you probably have similar scripts to deal with your own technical debt, because I don't think any business that is running for more than 5 years doesn't have technical debt. So just some examples. Based on this, we had a few requirements. We wanted to build a new monitoring solution. We decided to go with Icinga2 because it has it's had a similar way of working as Icinga1, so we hoped for a good migration path. But we had a few requirements. We wanted it to be 100% automated, so no engineer should change the configuration manually. No one should use SSH to log into a server and edit it and reload it. And if it doesn't work, then yeah, your production monitoring is down. We wanted it to be high available, so not 6 independent servers monitoring each other and stuff like that. We wanted a high available cluster with some failover functionality. So yeah, Icinga2 to the rescue here. We wanted to have a stage setup. We didn't want to continue developing in our live environment. I mean, I know in the software development world, it's a big trend to actually test in production because you test small changes and then you fail fast and fix it fast. But we don't want to develop in our live environment, in our monitoring, because our monitoring is the only way we survive as a managed hosting company. We need to see everything in our infrastructure, so we can't really fail fast in our live setup. So we decided to build a stage setup, especially to test new Icinga versions or our own patches and Icinga web modifications or new checks that we want to deploy. We wanted it to be maintainable, so not this bash script I showed you earlier. We wanted it to have in some way that everyone in the company could work with it if necessary, and that it would work for a long time in the future. And then we decided to do a full state migration. Nobody of us really anticipated how long it would take to do a full state migration. When I say full state migration, this means that we have thousands of checks in Icinga1 and a lot of runtime modifications, like someone acknowledged an alert, someone scheduled a manual downtime, someone disabled a check, someone disabled a notification. And you said earlier, yeah, don't take this crap with you. But we decided we want to take this crap with us because we don't want to start Icinga2 and then have thousands of alerts firing, sending SMS to our customers, and then telling our customer, yeah, it's nothing, it's just monitoring, we are acknowledging this now. We wanted to make a clean migration to make it as smooth as possible. And this took a lot of time. We wrote software to deal with it, and I will show it later to you. But first, let's talk a little bit about 100% automation. When I'm at stage and I'm drinking, I'm always afraid the recording will be like, look, look, look. So I hope it doesn't. So Icinga2 configuration. There are different ways to configure Icinga2. One way is to use the Icinga director. I guess most of you heard about it. We are not using the Icinga director. Another way is to manually edit the configuration. We did this before, so we are not doing this anymore. Then there are a few different ways to deal with it. Some people are using Ansible or some self-written bash scripts or stuff like that. We are using Puppet. There are two upstream Puppet modules from the Icinga developers. It's one for Icinga2 and one for Icinga Web2. They both work pretty awesome, so we are using them. Also because we are using Puppet to manage all of our infrastructure, so it makes a lot of sense for us to continue using Puppet for Icinga. We wrote our own Puppet module. It's SysEleven Icinga2, and it's a wrapper around both upstream modules, and we use it on all our monitoring servers. So on the Icinga masters, the satellites, the database servers, and the Icinga web servers. And yeah, it's able to rebuild the whole monitoring infrastructure from scratch. We tested this, and it works. So currently, I think it's one of our biggest Puppet modules because it does a lot of stuff. It has a lot of options. It can detect whether it's deploying a live configuration or a stage configuration and things like that. So this module deploys our monitoring. Then we wrote a second module, SysEleven monitoring. It's an extremely small Puppet module. And the only thing it does is it is used by us on every host we want to monitor. And then it's registering the host into our monitoring. So yeah, that's a small module, but everything that is using the SysEleven monitoring module will be monitored by our Icinga setup. Who in this room is familiar with Puppet? Okay, that's also quite a few people. If you are not familiar with Puppet, in Puppet you can have a Hira backend. It's a key value storage. And in the end, it's just a Git repository for us with a bunch of directories for every customer and a YAML file for every host. And if you want to change a setting for one host, we just added the YAML file, commit it to the Git repository, push it, and it will be used by Puppet to configure our hosts. This is not monitoring specific. This is how our Puppet workflow is for all our configuration changes. So now we have two Puppet modules that manage everything. How does it work? Puppet has one huge advantage compared to tools like Ansible. It has a persistent state across all your Puppet runs. So you have a Puppet database that knows what happened before. So if we are using our SysEleven monitoring module on the hosts we want to monitor, they will export information, they will export resources into the Puppet database about this Puppet run. And because we are using the upstream Puppet Icinga module, it will export a resource called Icinga2 host object or something like that. So if you have our 3,000 hosts using the SysEleven monitoring module, you will end up with 3,000 host resources inside of the database. And then later, we are running Puppet with the SysEleven Icinga2 module on our Icinga master, and it will collect all host objects from the Puppet database and generate an Icinga2 configuration file based on it. So that's all the magic we need to get all hosts into our monitoring. It has also some implications. For example, if you don't run Puppet, you won't have monitoring. So everything that is monitored by the setup has to run Puppet regularly. Okay, now we have all hosts available in our monitoring setup. But how do we know what do we check? So a basic host will have like maybe 10 or 15 checks for load and disk and stuff like that. But what if we run an actual application inside of the machine? As I said, we are using Puppet for everything. And so we are using Puppet, for example, to configure MySQL. If you don't know Puppet, this is Puppet code. And it's from our module that manages MySQL, and we have a check in MySQL. It's called MySQL InnoDB. It checks some buffer sizes and if they make sense. And now we are using our own SysEleven monitoring module inside of the MySQL module. SysEleven monitoring register var. It's a function that is provided by our SysEleven monitoring module, and it just registers a variable called MySQL InnoDB. And this is used to tell our monitoring infrastructure, okay, this host is using MySQL, and please execute a check called MySQL InnoDB regularly. And it always comes with some sane defaults. So if we are building a Puppet module for MySQL, our engineers will check which thresholds make sense to actually monitor a MySQL server. So by default, it already will use values that make sense to monitor this MySQL instance. But we want to be able to override everything. So and we are using Hira for that. Hira, as I said, are a bunch of YAML files. You have one file for every host. And now this is a file inside of this Git repository. And again, we are using the SysEleven monitoring module to register a configuration hash, again for the check MySQL InnoDB. And we are overriding settings like the max check attempts, retry interval, or we want to notify our customer. It's possible to override every available Icinga2 setting at this point. So our engineers really can change everything they want to for a host or for services. And some values will be transferred from the host to the service if it makes sense that you override all settings. For example, we use notify to decide whether to notify us or the customer, depending on the check. And then this will be applied to all checks of a host. And then our engineers will commit it to the Git repository, push it, and then we will do some sanity checks to verify that the new configuration makes sense. Because, of course, you can write stuff there like, please notify only the customer, but the check has a service level agreement. That are situations that don't make sense. If a check has a service level agreement, we have to notify the SysEleven support and not our customer. So in the beginning, we had a few times when Puppet generated a configuration that was broken and Icinga wouldn't restart. But now we have a lot of checks inside of our Puppet code that verifies that the generated Icinga2 configuration is actually working. And so this works pretty great. And it avoids that our engineers need to edit any Puppet code. They don't need to change stuff on the monitored hosts. They only need to change stuff inside of the Hira files if they want to modify our monitoring. We don't only want to override settings of existing checks, we also want to add new checks. We are primarily a web hosting company, so we have a lot of HTTP checks, and an HTTP check is always a custom check because usually you want to adapt it to the actual customer setup. You want to verify that the response is valid, contains some strings or stuff like that. So again, we are using Hira, and our engineers can simply add a SysEleven monitoring HTTP checks hash into it, and then they can add as many checks as they want. And it's enough if they only configure a host name or an IP address, and the rest will fall back to same default settings. But if they need to, they can override every setting that is available for an HTTP check. Then they just commit it to the Git repository, and it will be deployed. The same goes for NRPE checks. So yes, we are using NRPE for that, but you can, similar to the HTTP check, just add any check you want, and it will be deployed to our monitoring. So that's a summary of how we export stuff from our monitored hosts into the Puppet database, and then it will end up in our Icinga2 configuration. I considered talking longer about the part of how do we import it into the Icinga2 master, but it's quite complex because we are using the upstream module. When we started to use it, a Puppet run took about 15 minutes to generate the Icinga2 configuration. And a usual Puppet run in our setup takes about 5 seconds, sometimes 10 or 15 seconds. And with a lot of changes, it can take 1 minute, but a usual Puppet run never takes 15 minutes. So this was bad. We spent about a week to profile our Puppet server and to check how the upstream module works, and we learned a lot of stuff, and we also figured out how the module works. And to provide its full functionality, it does a lot of stuff with the imported resources. But we know our infrastructure, so we can make a few assumptions about our input values. So now we replaced some parts with custom Puppet cran. We use the upstream module to transform our own results into the Puppet objects that are used by the Puppet module. And I think it would take about 2 hours to really show how this works and why it works and why we did it. But in the end, we will end up with all host objects inside of our Puppet Icinga configuration. But I think the more interesting part about configurability is the part how we export the resources. So now we have a bunch of large configuration files in Icinga. And how do they look after we executed Puppet on the Icinga master? Earlier, everyone said that they know Icinga2, so you probably know what this is. It's a host object inside of Icinga2. And at the bottom, there are a few custom variables that are all configured by Puppet, like is it a virtual machine, who is the customer, what OS is running, the customer has a service level agreement. So for example, our Puppet server is talking to an API to figure out if this host has a service level agreement, and then it will write it to the configuration file. But the really interesting part is at the top. It's the check array, including MySQL InnoDB. So because our MySQL module registered the variable MySQL InnoDB, we will end up with a line check MySQL InnoDB enable equal true. And this is in the host object in our Icinga2 configuration. It's only a variable, it's not a service yet, so it will do exactly nothing except being there. So we need to create some service checks. And we are using the assign logic from the Icinga2 language. And it's a powerful templating language because now at the bottom we have a line assign where host was check MySQL InnoDB enable equals true. And this means that for every host where this variable is set to true, Icinga2 will create a check and execute it. And so only based on the variable in the host object, it will create a bunch of checks. For example, InnoDB, or if you're running an Apache server, it will create some default HTTP checks. There are a few more values, but most of them are common, like display name, check command, and stuff like that. Then we have some custom variables for the documentation and SLA and who we want to notify. But now, where do we actually override all the settings? I said our engineers can change everything inside of Hira. This happens inside of the imported template at the bottom again. Import generic service single, and this file just includes a lot of if else, if else, if else, and it will check if a different check interval is configured, then use the different one. And this for every available option. And if it's not overwritten in Hira, then it will just configure nothing and therefore use our default values. Right, so that's how we automate our full configuration of Icinga2. We usually end up with 2 huge host files and 1 huge service file which is only using the apply logic. Then a few words about high availability. It was our second requirement. We'll give you a second to get an overview of the confusing picture. Okay, so on the from the left side we have our Icinga2 cluster, and on the right side we have our Icinga Web interface. So on the left side we are using 6 Icinga2 zones, so I guess it's a lot less than most of you use, but we are not using the Icinga2 agent, so we only need 6 zones. We have a master zone with 2 masters, and then in every data center we have 2 satellites in 1 zone. And then we have 2 smaller management zones with only 1 satellite and 1 large global zone to synchronize some configuration files. We tried to have 3 satellites in each data center zone. Maybe you tried it. You shouldn't try it at home because there will be created some loop and everything is on fire then. But it works with 2 satellites, and it's also in the documentation that you shouldn't use more, so it was our own fault to try 3. But yeah, just use 2. And then our satellites are executing all checks via NRPE on our hosts if necessary. So usual configuration will mean that we execute Puppet on master 1, then the cluster functionality of Icinga will synchronize all files to the other satellites and the other master. And then you have 1 master who is writing into the IDODB. And the last talk was about a replacement for IDODB, so we are looking really forward to it because the dumping into the IDODB in our setup takes currently about 5 minutes. That's a lot of time, and then we have outdated information in the Icinga web interface because it will be only refreshed after 5 minutes. And then we are executing Puppet every 30 minutes, so Icinga will reload every 30 minutes, and every 30 minutes we will have 4 to 5 minutes delay in our Icinga web interface. So yeah, that's not great, but it works, and we are really looking forward to an IDODB replacement. And Icinga Web will use the information from the IDODB. It's on the right side, and we are using Anycast to route the traffic to the right data center. Then we have a pair of hardware load balancers in every data center, and behind every load balancer there are 2 Icinga Web backends. So there's a really, really, really small chance that our Icinga Web interface will actually fail. It never happened until now, and I hope it won't. And yeah, one last part in this diagram is at the top. It's an Elasticsearch cluster. We are using Icinga Beat to ship all Icinga2 events into the cluster. And our service management and our incident response team is using it a little bit to analyze which alerts happen most often or which alerts are most expensive. But there's no complex usage of it. It's just very simple until now. So yes, that's our high available setup. How high available is it? Everything that is red can fail, and we will still have a working monitoring. We won't have a web interface anymore, so we won't be able to acknowledge checks in the web interface. We can't force rechecks and stuff like that. But we will still have 1 master and 1 satellite in every zone, so we will still receive all important notifications. We will still receive all recovery notifications. So in the worst case, it will still work if this happens. And I think it's not too bad that if this happens, all web servers are offline, because if all web interfaces are offline, there are probably more or less 2 data centers offline. And yeah, I guess Icinga won't be our primary issue if this happens. And yeah, when we tried out Icinga2, we played a little bit with the failover mechanisms. And yes, it works if we just start to shut off Icinga masters and satellites, so we're very happy with it. And we don't only have 1 of those setups, we have 2. One is the production setup that actually sends out notifications to our on-call people or to our customers. And then we have a second one. If you already automated everything, it's really easy to build a stage setup because you just need to build a second one and it will be there. You only have to make sure that it does not start to send notifications to your customers. Because in our live setup, our engineers will acknowledge an alert usually in 5 or 10 minutes, but in our stage setup, nobody ever acknowledges an alert. So there are a few alerts where the customer said, yeah, it's okay, we will work on that later. And now if our stage setup would start to send notifications, there would be hundreds of notifications, so this wouldn't be good. But everything else works in the same way as our production environment. It is configured with the same hosts and the same services, and it uses the same intervals. So when a new Icinga2 version is released, we can deploy it in our stage environment, and we get a really good overview if it works. And it saved us several times if there was an issue. Sometimes we hit some edge case, which only happens if you have enough hosts or stuff like that. In the past, there was a MySQL release. It was a minor patch release. We updated it in the stage environment. And as soon as someone started to use Icinga Web, the MySQL server ZAC faulted. And we were like, okay, it's good that this is our stage system. And then we had to downgrade this MySQL server, and based on the schema changes, we had to wipe the whole database, and we are very happy that this happened in our stage environment. And we were able to debug it, and upstream is still working on a MySQL fix, because it only happens if you use the memcache plugin of MySQL. So apparently there are not a lot of people doing that. But yes, so a stage environment is really important for us. And I guess a lot of you are still thinking about the little errors saying NRPE. Why on earth is SysEleven using NRPE in 2019? There's the Icinga2 agent, it has authentication, it has encryption, it has a modern code base, it is actively developed, but we are not using it. So when we decided to migrate from Icinga1 to Icinga2, we knew this will be a huge project, and we don't want to make it any bigger, because if we do more stuff at the same time, there's a high chance that we will fail. So we decided, okay, all our Puppet module have perfect NRPE support, all our deployed checks make sense, it's okay if we continue to use them. All NRPE connections are inside of our own data center. There is no one allowed in the data centers except this SysEleven employees, so there isn't a large security issue. Even our security department and the Bundesamt für Sicherheit in der Informationstechnik are happy to certify us despite the fact that we do this. So there is an option to migrate to the Icinga2 agent later, but there's no need to currently. It works pretty well as it does, and so yeah, I could drop something like never touch a running system or stuff like that, but to be honest, it works for us, and so there's more urgent issues than introducing the Icinga2 agent. So, a few words about our migration. Migrating is harder than building from scratch. If you are building from scratch, you can just start using the Icinga2 agent. You won't have any weird data available that you have to migrate. You won't have any configuration built by a coworker who left 3 years ago and no one knows why is it built this way and do we need it like that. You can just start building. But we needed to migrate everything. We needed to make sure to not lose any hosts. We needed to make sure to not lose any checks. Or, okay, we lost a few checks, but it was an active decision to leave them behind because we don't need them anymore. But we wanted to know the difference between our old setup and our new setup. So we wrote a tool. It's called icingadiff, and it takes all information from our 6 Icinga1 servers. Then it takes all information from our running Icinga2 instance, and then it will compare it. It will compare the host, it will compare all services, it will verify if the notification settings are the same, it will verify if the contact details of all of your contacts are the same, and stuff like that. It was quite a huge tool, and with a lot of SysEleven internals. So we decided to remove all internal stuff and release it as open source. It's called Icinga2 migration utils. You can find it on GitHub. And yeah, it compares 2 running instances, and it's also able to migrate your dynamic acknowledgement downtimes and comments from Icinga1 to Icinga2. We used it to continuously migrate all the changes as they were happening in real time, and then synchronize it to the Icinga2 setup. If you are still running Icinga1, is anyone still running Icinga1? Okay, do you plan to migrate to Icinga2? Okay, so if you're early in your migration, then you may want to check this out. It's not a ready for production solution, but you can utilize it as a framework for your own migration. There are examples how we compared old checks to new checks because the configuration logic changed between Icinga1 and Icinga2. So there's some fuzzy matching for HTTP checks, for example, but maybe it will give you an idea how to do your own migration. At the OSMC, someone talked to me and he said, that's nice, we did it in another way. They used the MySQL InnoDB, InnoDB, because it's the same schema, and then they just compared the content of the database to make sure that everything is still the same. And I also really like this approach. Okay, so we migrated everything, and we went live last January in 2018. And it worked so smooth, it was scary because there was lunch and we decided, okay, we will do it before lunch and then stay at the office while everyone else is gone. And yeah, we turned off the notifications of the old system and turned on the new ones, and that was it. We started to eat pizza and everyone was fine. And there were no crazy notifications sent out to customers or anything. It was just, it worked. Our engineers started to use a different web interface. The notification emails looked a little bit different, but that was it. Of course, in the next few weeks, we found a few minor issues and fixed it, but there wasn't a huge downtime, or we didn't have to make a rollback to Icinga1. So the Icinga2 migration new tools really did a good service for us. So I'm running a little bit short on time, so I will fast forward a little bit in the next few slides. We did a few Icinga Web modifications. If you know Icinga Web, you will realize that looks a little bit different. At the top, we have this service level agreement marker, and we use it to prioritize the alerts in our incident management. And this marker is based on the custom variable inside of the host or service, which you saw earlier at the bottom in the configuration file. Then we added a part about additional documentation. So it's also generated by Puppet. For example, Puppet figures out on which hardware a machine is running, and then it will insert links to the hardware node monitoring or the hardware node trending and stuff like that to the customer documentation. And if we have a custom check for some customer, we will add documentation for that. So our support engineers can just click on it and be at the right place and not start to search in the wiki manually. So yeah, I like this because it's a small change, but it's super helpful for other people. Then another change we made is last acknowledgements. A coworker came to me and said, the history tab of Icinga Web is nice, but it's slow. And sometimes we have a lot of flapping states in there, but we only want to know, is there an existing ticket in our ticket system? And then I talked to another coworker who knows stuff about the Icinga2 web framework, and he explained to me how it worked. And I was able, with 50 lines of PHP code, to get the last acknowledgement messages from the database and display them here. And now we have a link to existing tickets, and our incident response team can just see, okay, there's already an ongoing investigation. There's already communication with our customer happening. So it's a lot better if you start to add new information to the existing ticket than just create a new one and the customer says, hey, we already have a ticket for that. So yeah, that's a nice change. Then we changed the way we acknowledge alerts. We developed a feature, ACTU Ticket, and it's where you are able to create a Zendesk ticket in the second you acknowledge an alert in Icinga. You can also create one ticket for all services of one customer, for example. That's super helpful because now we have one continuous workflow. We acknowledge an alert, then a ticket will be created, and the ticket will also contain links to all additional documentation. So our incident response team does not need to leave Icinga Web until the ticket is created and they start debugging the issue. And during the OSMC, I promised you that we will open source the modifications and that we want to bring them back upstream. In January, we created our first feature request or feature pull request for Icinga Web. Our earlier pull requests were only like documentation improvements or bug fixes, but now we are starting to contribute features. But it's a different feature than I showed at the OSMC. It's another modification we made. We added a check all button. Maybe some of you know when you reboot a host and all checks are critical and you just want to recheck all checks of this host, then you have to select all services and click check now. We added a small button, check all now, and this works pretty well. It's not merged yet, but I guess it will be sometime soon. Okay, so that's about our Icinga Web modifications, and I hope that we will release the rest of it anytime soon. Currently, we have a little bit of problems to merge the last Icinga Web release with our own modifications. So if we sorted that out, we can update our own Icinga Web and then maybe create pull requests. If you like this change, just give it some emojis, maybe it will help. Okay, so the headline is the same as in November, tips after 1 year. So in November it was like nearly a year. Now it's a little bit more than a year that we are running this. And yeah, my major takeaway is please build a stage setup. In some way you need to check your changes. You need to verify Icinga2 updates, because if you don't and if you just update your production setup, at some time it will probably break. And if you are dependent on your monitoring, then this shouldn't happen. And yeah, automate everything. This helps a lot. And I guess a lot of people are already doing this because it's 2019. But usually we always have companies that are a little bit slower. Like us, we had Icinga2 until last year, Icinga1 until last year. So there are probably still manual edits happen. Don't do this anymore. Also, it helps a lot to track all related issues on GitHub, like Icinga, Icinga Web, Icinga Packaging, Icinga Beat, everything. And then you will be part of the community. You will start to know, okay, who works at this and what is happening. But it will also help you in your own debugging, because now you already know, okay, before the last release, there was someone who had a similar issue. Maybe it's related and stuff like that. Personally, I find this super helpful to know what's happening in the Icinga2 development. Also because I think it's so important, please build a stage setup. And well, is it perfect? And now after like 14 months with it, we had no major outage in the live environment. We had several major outages in our stage environment, but nobody cared about it because I just figured it out, what was broken with our update, then tried it again, and then when we were sure that it's working, we deployed it to production. So yeah, there wasn't an outage, and when some part of our Icinga live environment failed, then it was like one satellite because the hardware broke down. But it didn't matter because we have a second satellite, for example. So my last message is please talk about your setups. As I said in the beginning, I'm doing this to share our knowledge and to inspire you to share your own experiences. And it worked pretty well during the OSMC. So I would love to talk to you about your own issues. And I'm still in regular contact with a few people from the OSMC. For example, there's Marco, who has a similar setup, and sometimes he writes me a mail or I write to him like, yeah, with the new Icinga version we have this issue, and then we usually write back, I can't see this at this time. And then 2 weeks later, there will be a next mail, yeah, we have this too now. And so it's super helpful to talk to each other, and then we can create an upstream issue where we explain our issue after we understood it. So if you are from Berlin, we have an Icinga2 meetup in Berlin. It happens once a month or every second month. Please join us. We need more people there, and we also need more people talking about their own setups at this meetup. So please join the meetup. There are also meetups in, I think, Hamburg and Salzburg and Vienna. I don't really know, but it's all online. Please join the community. And I mean, you already know it because you're here, but please still join. So thanks for listening. If you want to reach out, I have a few contact details, and I'm super happy to answer all your questions.